Welcome to this presentation on logarithm properties. Now this is going to be a very hands-on presentation. If you don't believe that one of these properties are true and you want them proved, I've made 3 or 4 videos that actually prove these properties. But what I'm going to do is I'm going to show you the properties and then show you how they can be used. It's going to be a little more hands-on. So let's just do a little bit of a review of just what a logarithm is. So if I say that a, oh that's not the right. Let's see. I want to change. There you go. Let's say I say that a. Let me start over. A to the b is equal to c. So if a to the b power is equal to c. So another way to write this exact same relationship, but instead of writing an exponent, is to write it as a logarithm. So we could say that the logarithm base a of c is equal to b. So these are essentially saying the same thing. They just have different kind of results. In one, you know a and b, and you're kind of getting c. That's what exponentiation does for you. And the second one, you know a, and you know that when you raise it to some power, you get c. And then you figure out what b is. So they're the exact same relationship, just stated in a different way. Now I will introduce you to some interesting logarithm properties, and they actually just fall out of this relationship, out of this relationship and the regular exponent rules. So the first is that the logarithm. Let me do a more cheerful color. The logarithm, let's say of any base. So let's just call the base. Let's say b for base. Logarithm base b of a plus logarithm base b of c, and this only works if we have the same basis, so that's important to remember. That equals the logarithm of base b of a times c. Now what does this mean and how can we use it? Or let's just even try it out with some I don't know, examples. So this is saying that I'll switch to another color. Let's make mauve my mauve. I never know how to say that proper. Let's make that my example color. So let's say logarithm of base 2 of of 8 plus logarithm base 2 of let's say 32. So, in theory, this should equal, if we believe this property, this should equal logarithm base 2 of what? Well, we say 8 times 32. So 8 times 32 is 240 plus 16, 256. 256. Let's see if that's true, just trying out this number. And this really isn't a proof, but it'll give you a little bit of an intuition, I think, for what's going on around here. So we just use our property, this little property that I presented to you, and let's see if it works out. So log base 2 of 8. 2 to what power is equal to 8? Well, 2 to the third power is equal to 8, right? 2 to the third power is equal to 8. So this term right here, that equals 3, right? Log base 2 of 8 is equal to 3. 2 to what power is equal to 32? Let's see, 2 to the 4th power is 16. 2 to the 5th power is 32. So this is right here is this is 5, right? And 2 to the what power is equal to 256? Well, let's see. Well, if you're a computer science major, you'll know that immediately, that a byte can have 256 values in it. So it's 2 to the 8th power. But if you don't know that, you could multiply it out yourself. But this is 8. And I'm not doing it just because I knew that 3 plus 5 is equal to 8. I'm doing this independently. So this is equal to 8. But it does turn out that 3 plus 5 is equal to 8. This may seem like magic to you, or it may seem obvious. And for those of you who it might seem a little obvious, you're probably thinking, well, 2 to the third times 2 to the 5th is equal to 2 to the 3 plus 5, right? This is just an exponent rule. What do they call this? The additive exponent. I don't know. I don't know the names of things. And that equals 2 to 8, 2 to the 8th. And that's exactly what we did here, right? On this side, we have 2 to the third times 2 to the fifth, essentially. And on this side, you have them added to each other. And what makes logarithms interesting is, and why it's a little confusing at first, and you can watch the proofs if you really want a kind of a rigorous, not even my proofs aren't rigorous, but if you want kind of a better explanation of how this works. But this should hopefully give you an intuition for why this property holds, right? Because when you multiply two numbers of the same base, right, two exponential expressions of the same base, you can add their exponents. Similarly, when you have the log of two numbers multiplied by each other, that's equivalent to the log of each of the numbers added to each other. This is the same property. If you don't believe me, watch the proof videos. So let's do let me show you another log property that's pretty much the same one. I almost view them the same. So this is log base b of a minus log base b of c is equal to log base b of, well, I'm running out of space, a divided by c. That says a divided by c. And we can once again try it out with some numbers. I use 2 a lot just because 2 is an easy number to figure out the powers. But let's use a different number. Let's say log base 3 of I don't know, log base 3 of, well, let's make it interesting. Let's log base 3 of 1/9 minus log base 3 of 81. So this property tells us that this is the same thing as, well, I'm ending up with a big number, log base 3 of 1/9 divided by 81. So that's the same thing as 1/9 times 1 over 81. I use 2 large numbers for my example, but we'll move forward. So let's see, 9 times 8 is 720, right? 9 times 8 is 720. So this is 1 over 729. So this is log base 3 over 1 over 729. So what does 3 to what power is equal to 1/9? Well, 3 squared is equal to 9, right? 3 squared is equal to 9. So we know that, if 3 squared is equal to 9, then we know that 3 to the negative 2 is equal to 1/9, right? The negative just inverts it. So this is equal to negative 2, right? And then minus 3 to what power is equal to 81? Let's see, 3 to the third power is 27, so 3 to the fourth power. So we have minus 2 minus 4 is equal to, well, we could do it a couple of ways. Minus 2 minus 4 is equal to minus 6. And now we just have to confirm that 3 to the minus 6 power is equal to 1 over 729. So that's my question is 3 to the minus 6 power, is that equal to 1 over 729? Well, that's the same thing as saying 3 to the 6th power is equal to 729, because that's all the negative exponent does, is inverts it. Let's see, we could multiply that out, but that should be the case because, well, we could look here, but let's see, 3 to the third power, this would be 3 to the third power times 3 to the third power is equal to 27 times 27. Now, that looks pretty close. You can confirm it with a calculator if you don't believe me. Anyway, that's all the time I have in this video. In the next video, I'll introduce you to the last 2 logarithm properties, and if we have time, maybe I'll do examples with the leftover time. I'll see you soon.